A great piece of advice for any programmer out there is to learn a new programming language from time to time. In the Pragmatic Programmer book, the authors suggest to learn a new programming language every year. I decided to follow this advice in 2024 and included it in my yearly goals. I've chosen Rust, which is a pretty popular choice for a new programming language to learn these days. I've spent a month reading the book, trying out the examples from it, and trying to solve some leet code kind of problems with the language. After that, I felt confident enough to create something completely on my own. I decided to make a snake game. The game logic is simple and the graphics can be minimal, which is suitable for a terminal. So what can be learned from such a simple project? It turns out quite a lot. This is my post-mortem for this little project. Don't expect it to be very educational. A snake game requires real-time rendering. Well, kind of. It should update the game state and the screen at set intervals and be able to process users' input at the same time. One way of doing it, which makes the most sense in this situation in my opinion, is to spawn a thread that will do the state update and rendering in an infinite loop while the main thread is blocked most of the time awaiting for the user's input. So right away we are delving into the realm of not so basic stuff related to sharing data between threads. It is quite a simple case, however, so shouldn't be too complicated to navigate. Let's create a new thread to update and print the current game state, and a loop in the main thread to read users' input. Rust standard library doesn't have an equivalent of getChar function from the C library. There are good reasons for that which I don't fully understand yet. Turns out I have some blanks in my knowledge about how the standard I/O works. But for now I can work on filling these gaps later. I'm going to use the console crate, which in my understanding is the de facto standard for working with terminals and standard I/O. Now we can start printing the game field in the game thread. For now it's just empty. Let's represent empty squares as dots. And I think it's time to start implementing some kind of movement and consequentially communication between the main and game thread. We will need to pass the change in the direction from the main to game thread. I'm creating a struct to hold the state of player input. We only need two things: the current direction of the snake and the direction the snake should take on the next game states update. The idea is that the latter can change multiple times while game states update thread is sleeping, but we need to make sure it's never in conflict with the current snake direction. So if the snake currently moves horizontally, we can only change its direction to vertical and vice versa. I probably love enums a bit too much, and I'm going to use them as much as I can in this project. I will use them to represent the direction of the snake movement, and also to represent the kinds of tiles on the field, which are empty, snake part, and food. For the direction, I will even use nested enums, as the movement can be either horizontal or vertical, and both of them can be either positive or negative. Of course, I could implement it using just one enum, say left, right, up, and down, or some other way, but it wouldn't be as fun. I will also need a struct to represent a position on the field by the row and column index. I will use it to keep track of the current position of the snake's head and tail, and each part of the snake should know the location of the next part on the field. Let's place one tile representing the snake's head on the field, and make it move in accordance to the direction on every update. And also let's update the direction every time the user hits arrow keys in the terminal. This is where it comes to a tricky part where I will need to share the state of snake direction between the threads. I'm using Arc and Mutex to share this state between threads. I'm still wrapping my head around all this concurrent programming stuff. Although I have some experience with it from the good old days of programming in C, all this knowledge is buried under years and years of mindless web development. While implementing this, I've experienced one of my first aha moments in learning Rust. After reading the documentation, looking at examples, and discussing the subject with ChatGPT, I wrote the code as you can see it on your screen. But it didn't work as I expected. When I hit keys to change the direction of the snake, the game update thread just ignored it, and the snake head continued to move in the initial direction no matter what keys I hit in the terminal. I tried many different things, such as staring at the code for minutes, moving the cursor back and forth, saving the code and trying to run it again. Nothing worked. I read the documentation several times, looked at the code, read the documentation, and then For some reason it wasn't immediately apparent to me that the value obtained from the mutex lock never goes out of the scope, as long as the loop is spinning. Everything inside it remains within scope until the loop breaks. It might sound kind of silly, but I want to believe that this realization and the way I've solved it brings me a bit closer to being able to think in Rust. But let's get back to implementing the game logic. The head will move to the next cell, leaving behind a snake piece tile with coordinates of the cell the head moved to. Tail of the snake should move to the cell occupied by the next snake part, leaving an empty cell behind itself. Now let's implement food. You can start roasting my code here. I wanted to create a closure that will access the field which is defined out of its scope. Find one random empty cell from it. The compiler wouldn't let me do it, and with my very limited understanding of ownership and borrowing so far, I ended up adding a reference argument to the closure, so making it a closure kind of doesn't make any sense anymore. But it works, so I am moving forward. The logic could also be optimized, but for a small field like this, it's good enough. The logic behind growing the snake after a piece of food has been consumed is very simple. Check if the head moved into the cell with a food tile, and if it is the case, skip pulling the tail piece forward for this update. In other words, only pull the tail if the entered cell is empty. This will make the snake one piece longer every time food is consumed. Also, it is a good time to add the check if the head is moved into another snake tile, which will result in a game over. In this case, we can just show the message and shut down the game. And here I am calling it done. So that is it. I will add the GitHub link into the description, but please keep in mind that I'm in the very beginning of my Rust learning journey, so it is definitely not the best code to learn from. What can I say about my experience of using Rust so far? I love it. Yes, fighting with a compiler feels frustrating at times, but the result of these fights is always a better code, so it's worth it. I was also pleasantly surprised to find features like enums and pattern matching, which I already appreciate from my experience with the Hex programming language. My plan is to continue learning throughout this year. I also plan to make more videos about this journey. But that's all for this video. Bye!